That's fine.
So I'm just kind of going through my thought process on how I would look at a polynomial and factor and find all the real zeros. This is lesson 3.4. And first thing I would think of is we're learning about this rational zero theorem in this lesson. And that means I have to look at all the factors of P, which in this case is a 0, and Q, which is a 1. But what I'm going to start off the bat looking at is I can really see that I could factor out an x from all of these terms. So I'm going to factor out an x out front. That leaves me with x cubed minus 13x minus 12. Now I know I have a 0 at x equal to 0. I know that's one of them because I factored out the x. So that leads me to one of my zeros right away. So 0, 0. I also know because my highest term is an x to the 4th, and my leading coefficient on that x to the 4th is a positive 1. So it's going to both end facing up. There's going to be some terms in between there. And I know that my leading coefficient or my leading exponent is a 4. So there's going to be 4 minus 1 up to 3 terms somewhere in there. Now, it doesn't mean they're all going to be zeros. It doesn't mean there's going to be 4 real zeros. It means like I could have some zeros that don't cross the x-axis. So I could have, it could cross, I know it crosses at 0 at some point. It could come down here and turn. That could be one of the turns, and then it could go up. So one of the turns might be one of these 3 terms that don't actually cross the x-axis to be a 0. And we're going to learn about those imaginary turns and imaginary zeros later in chapter 3. So now that I've got this factored, I can now look at this x cubed minus 13x minus 12, and I can look at this with the rational zeros theorem because I do have a constant here on the negative 12. So I could look at all of the factors, and my Q here is a 1, so that makes it easy. So I'm really just looking at all the possible factors of 12. So I could look at the possibility of plus or minus 12, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6. These are all factors of 12, a negative 12. And I'm going to start with the easiest one, a factor of 1. So if 1 is a factor, then I'm going to use my division here, and I am going to use 1, and then I don't have a square term, so I have to use 0 on the synthetic, and then a negative 13 and a negative 12. Okay. So if 1 is a root, that means x minus 1 is the factor, because remember, I have to set it equal to 0. So my synthetic division, I'm going to bring down my 1, and then I've got 1 times 1 is 1. I'm going to add 0 and 1 to get 1, and then 1 times 1 is 1. And then a negative 13 plus 1 is a negative 12. And then 1 times a negative 12 is a negative 12. And when I add those, I get a negative 24. So this tells me a couple things. 1 is not one of my zeros. So x minus 1 is not one of my factors. But we got so close because all I needed was for this negative 12 to be a positive 12, and it would add to 0, and it would be a factor, and it would be a 0. So I'm going to scrap this and try a negative 1. So again, rewriting my coefficients. Always remember, if you don't have a term, you have to fill it in as a 0. We don't have an x squared term, so that has to be a 0. Okay. So I'm bringing down my 1. This becomes a negative 1. Add to 0, we get a negative 1. This becomes a positive 1. Add a negative 13 and a positive 1, we get a negative 12. Multiply a negative 1 and negative 12, we get a positive 12. And boom, we get a 0. So this is fabulous. So now we know we have x equals 0. We also have x equals a negative 1 is one of our zeros. And now we have left an x squared minus an x minus a 12. So that's, so off to the side, this is what it should visualize. This should be x times x plus 1 times this x squared minus x minus 12. This all multiplies to make our original. But there's still a possibility that this x squared minus x minus 12 factors or has another 0. And I'm always going to, once I get to a trinomial, an x squared, an x, and a constant, I'm always going to just try factoring first, because once you're feeling good about your factoring skills, that's your easiest bet. And so I can see there's a 1 on my x squared, so it kind of makes it easy if it does factor. And I've got an x minus 4 and an x plus 3 that they add to make the -1, and they multiply to make the -12. So I have x plus 1, x minus 4, and x plus 3. We're going to go to Desmos and validate here in a minute, but it should look like this. This is where it gets exciting, because it's like, I want to challenge myself to see if I can do this without my Desmos help. So it looks like I go through x at 0. I go through at a -1. I go through at a +4. So 1, 2, 3, 4. And I go through at a -3, a -2, a -3. And I go through at a -3. And because they all are singular as far as factors, I've got 1, 2, 3, 4, which is my highest power, right? My highest exponent is 4. That's my 4 roots. I don't have any imaginary. So all of my terms are going to be with these roots, and they all cut through. And we know that they face up. We discovered that earlier. So it faces up, it comes down and does something. We don't know, but it turns and cuts through, goes up, does something, cuts through at 0, goes down and cuts through and does something. And then this is not that. It comes up and cuts through at 4. I might have said a -4 over here. It's a -3. So let's just go to Desmos and see if we, in fact, did it correctly. This is super exciting. We're going to go to Desmos. And I don't need all these weird things open here. Okay, so I'm going to type in my original y equals x to the 4th minus 13x squared minus 12x. Let's make sure oh, look at how pretty that is. Now you can go over here and zoom out if you'd like a little bit. Oh, wow. And look at, we couldn't tell what it's doing down here, and we couldn't tell what it's doing down here just from what we looked at. There's other ways to find those things, but in fact, we can go here and go, yep, there's a -3, there's a -1, there's a 0, and there's the +4. So super fun to be able to do all of that without looking at the graph in Desmos, but you can always use Desmos as a check, right? Just to verify you know what you're doing. So catch me back for another fun video.